What if the most unprecedented military gathering in modern American history was not called because of earthly threats, but because something extraordinary is racing through our solar system right now? Something that has Harvard astrophysicists questioning everything we thought we knew about interstellar visitors and Pentagon officials privately asking whether we might be witnessing our first encounter with technology from another star system. Welcome to another deep dive into the intersection of cutting-edge science and the mysteries that keep us wondering about our place in this vast cosmos. If you enjoy exploring the frontiers of knowledge, where hard science meets tantalizing possibilities, smash that like button, hit subscribe and tell me in the comments where you're watching from, what time it is there, and the strangest unexplained thing you have ever witnessed. Now, let us dive into a story that is unfolding right above our heads at this very moment. On September 25th, 2025, Defense Secretary Pete Hegseth issued an order that sent shockwaves through military command structures around the globe. Every general and admiral with the rank of brigadier general or above, serving in command positions worldwide, was summoned immediately to Marine Corps Base Quantico in Virginia for an emergency meeting. No explanation, no agenda, just an unprecedented gathering of hundreds of the most senior military leaders on Earth, pulled from active deployments across 6 continents with 48 hours' notice. But here is what makes this story truly extraordinary. Just 2 months earlier, on July 1st, an automated telescope system in Chile detected something that would challenge our understanding of cosmic visitors and ignite fierce debates about the possibility of extraterrestrial intelligence. The object designated 3 Atlas was not just another space rock. This was the 3rd confirmed interstellar object ever discovered racing through our solar system on a trajectory so precise, so perfectly aligned with our planetary orbits that the statistical probability of such a path occurring by pure chance is less than 0.1%. According to NASA's official discovery announcement, 3EI Atlas was first spotted by the Atlas Survey Telescope in Rio Hato, Chile. The Asteroid Terrestrial Impact Last Alert System, designed to identify potentially hazardous asteroids, captured what initially appeared to be nothing more than a faint point of light. But as astronomers calculated its orbit, they realized they were looking at something unprecedented. The object was travelling at over 200,000 km on a hyperbolic trajectory, meaning it originated from beyond our solar system and would continue its journey into deep space after rounding our Sun. What sets 3I at last apart from previous interstellar visitors is not just its size, though early estimates suggested a diameter of up to 20 kilometres, making it by far the largest such object ever detected. What makes it truly remarkable is its behaviour, its trajectory, and the growing list of anomalies that have some scientists whispering about possibilities that would have been dismissed as science fiction just decades ago. Dr. Avi Low, the controversial Harvard theoretical physicist who previously suggested that the first interstellar visitor, one Oumuamua, might be artificial, has been raising increasingly urgent questions about 3E Atlas. In a series of papers and blog posts that have captured international attention, Low argues that the object displays characteristics more consistent with engineered technology than natural space debris. The evidence he points to is compelling and disturbing. First, the sheer size of 3 Atlas makes its discovery statistically improbable. Objects of this magnitude should be extraordinarily rare among interstellar visitors. The chance of stumbling upon such a massive object by random observation is calculated at approximately 1 in 10,000. Yet here it is, the 3rd interstellar object we've ever detected and by far the largest, 2nd The trajectory of 3 Atlas follows what can only be described as an optimal path for planetary observation. Rather than cutting through our solar system at some random angle, as would be expected from cosmic debris ejected by gravitational interactions in a distant star system, this object is travelling almost exactly along the plane of the planets. This alignment allows it to pass relatively close to Venus, Mars, and Jupiter, offering theoretical opportunities for detailed reconnaissance of each world's characteristics. But the most unsettling aspect of 3.2 at last may be its timing and destination. The object's current trajectory will carry it behind the Sun in late October 2025, providing a perfect opportunity for undetected course corrections. Any probe equipped with advanced propulsion systems could use this solar occultation to alter its path without human observers being able to track the maneuver. In essence, 3 Atlas will disappear from our view at precisely the moment when it could most easily change a course toward Earth. Doctor. The Loeb suggested that if 3E Atlas is indeed an artificial object, its mission might align with what science fiction author Lou Schickan called the dark forest hypothesis. This theory attempts to explain the Fermi paradox, the puzzling absence of detectable alien civilizations despite the vast number of potentially habitable worlds in our galaxy. According to this hypothesis, advanced civilizations remain hidden because the universe is filled with predatory species that destroy any civilization they detect. In such a cosmos, any alien probe would be designed for stealth reconnaissance, gathering information about potential threats while avoiding detection. The implications are chilling. If 3 at last represents our first encounter with extraterrestrial technology, its purpose may not be peaceful exploration, but systematic assessment of human capabilities and planetary defenses. The trajectory that brings it close to multiple worlds could represent a comprehensive survey mission, cataloguing everything from atmospheric composition to signs of technological development. These concerns, while dismissed by most mainstream astronomers as speculative fiction, would not be ignored by military intelligence analysts. The Pentagon has a long history of taking potential threats seriously, even when the probability of those threats is relatively low. The same institutional mindset that created Project Blue Book, the Air Force's 20-year investigation of unidentified flying objects, would almost certainly demand a thorough assessment of any credible scientific speculation about potentially hostile alien technology. In the context of national defense, the distinction between probable and possible takes on different meaning. While scientists require overwhelming evidence before accepting extraordinary claims, military planners must consider worst-case scenarios and prepare for contingencies that may never materialize. The discovery of an anomalous interstellar object combined with credible academic speculation about its potentially artificial nature would trigger classified discussions about appropriate response protocols. Consider the timeline that emerges when we examine these events in sequence. 3I at last is discovered in early July. Throughout July and August, astronomers worldwide conduct increasingly detailed observations using some of the most powerful instruments available, including the Hubble Space Telescope and the James Webb Space Telescope. According to NASA's mission updates, these observations reveal the presence of water vapor and carbon dioxide in the object's coma, suggesting typical cometary activity. However, other characteristics remain puzzling. The European Space A's frequently asked questions document about 3E Atlas notes that the comet's brightness variations do not follow expected patterns for a rotating nucleus. Its spectroscopic signature shows unusual features that are difficult to explain using conventional models of comet composition. Most significantly, despite supposedly shedding material into space as it warms near the Sun, 3I at last maintains a remarkably stable trajectory with none of the small deviations typically caused by outgassing. By September, enough data would have accumulated to allow intelligence analysts to conduct their own assessment independent of public scientific discourse. While astronomers debated whether the object showed clear signs of natural cometary behavior, classified discussions would have examined more troubling possibilities. What if the apparent cometary activity was camouflage? What if the stable trajectory indicated active guidance systems? What if the approach to our solar system represented the opening phase of a systematic survey or preparation for more direct contact? These questions would have made their way up the chain of command, eventually reaching the highest levels of the Defense Department. Secretary Hegst, already known for his unconventional approach to military leadership and willingness to challenge established procedures, would have faced a decision unlike any in modern military history. How do you prepare for a threat that may not exist, but if real, could represent an existential challenge to human civilization? The answer appears to have been the most comprehensive gathering of military leadership in American history. Every general and admiral, regardless of current assignment or operational sensitivity, was ordered to attend a classified briefing at Quantico. The secrecy surrounding this meeting was unprecedented. Even the officers themselves received no advanced information about the agenda. One anonymous official speaking to CNN described the atmosphere as resembling something from a dystopian novel, coining the phrase that the gathering felt like the general Squid Games. The logistics alone were staggering. According to reports from the Washington Post and CBS News, officers were pulled from active combat zones in the Middle East and Africa. NATO commanders left their posts in Europe. Pacific Fleet admirals interrupted ongoing exercises to return to American soil. The cost in terms of transportation, security, and operational disruption would have required approval from the highest levels of government, suggesting that whatever prompted this meeting was considered a matter of extraordinary importance. The choice of Quantico as the meeting location carries additional significance. While Marine Corps Base Quantico is known primarily for officer training, it also houses some of the military's most secure briefing facilities. These rooms, designed to prevent any form of electronic surveillance or communication leakage, would provide the perfect environment for discussing information too sensitive for conventional Pentagon briefing rooms. As reported by multiple news sources, the Pentagon's official response to media inquiries was limited to a statement that Secretary Hegst would be addressing his senior military leaders with no details about the meeting's purpose or scope. This level of secrecy, combined with the unprecedented nature of the gathering, created information vacuum filled by speculation and rumors throughout military and defense contractor communities. Meanwhile, 3i at last continued its journey through our solar system, growing brighter as it approached the sun and becoming accessible to increasingly powerful telescopes. Each new observation added to the mounting database of information about this mysterious visitor. Some findings supported conventional interpretation as an unusual but natural comet. Water vapor and carbon dioxide detected in the object's coma aligned with expectations for cometary composition. These observations were emphasized by NASA and mainstream astronomers as evidence that 3i was indeed what it appeared to be. However, other observations proved more troubling. A study published by researchers at Michigan State University revealed that 3e had been visible in archived images from NASA's Transiting Exoplanet Survey satellite dating back to May 2025, 2 months before its official discovery. This pre-discovery detection suggested the object had been active and observable for longer than initially realized, raising questions about why it had not been identified sooner by automated detection systems. Doctor. Lowe continued raising questions about these anomalies through his blog on Medium and academic preprint servers. His writing combined rigorous scientific analysis with speculative scenarios that captured public imagination. The possibility that humanity was experiencing its first contact with extraterrestrial technology, even in the passive form of an unmanned probe, represented a profound shift in our understanding of our place in the universe. Yet, for all the public excitement and scientific debate surrounding 3 Atlas, the most crucial discussions were taking place behind closed doors in secure government facilities. Intelligence analysts were conducting assessments of the object's characteristics using capabilities unavailable to civilian astronomers. Military space surveillance networks designed to track potential threats in Earth's orbital environment were being turned toward this interstellar visitor. The intersection of these two stories, the mysterious military meeting and the controversial comet, reveals the complex relationship between scientific discovery and national security in the modern world. When extraordinary claims are made about potentially extraordinary phenomena, the response must balance skeptical scientific inquiry with prudent preparation for unlikely but potentially catastrophic possibilities. What makes this story particularly compelling is how it unfolds against the backdrop of humanity's evolving relationship with the cosmos. For most of human history, the space between stars was considered an impossible void, a natural barrier that protected Earth from any external threats. The discovery of interstellar objects like Oumuamua, 2e Boros, and now 3i Atlas has shattered that assumption. We now know that matter and potentially technology can and does travel between star systems. The statistical analysis that makes 3 Atlas so intriguing also highlights how little we understand about the frequency and nature of interstellar visitors. If objects of this size are as rare as calculations suggest, then finding 3 such visitors in less than a decade implies either extraordinary luck or a fundamental misunderstanding of interstellar object populations. Some astronomers have suggested that our improving detection capabilities may simply be revealing a previously hidden population of cosmic travelers. Others, like Dr. Lowe, argue that the unusual characteristics of these objects demand more exotic explanations. The debate extends beyond academic circles into the realm of practical policy. How should governments respond to discoveries that challenge our understanding of cosmic phenomena? What protocols exist for evaluating potential threats from space? How do intelligence agencies assess claims about extraterrestrial technology when the evidence remains ambiguous? But the potential implications are enormous. These questions become even more complex when we consider the international dimensions of space-based threats. 3SI at last is not approaching just the United States, but Earth as a whole. Any potential danger it might represent would affect all of humanity. Yet the response, at least as evidenced by the Quantico meeting view, appears to be primarily national in scope. This raises uncomfortable questions about how global threats are managed in an era of international competition and mistrust. The scientific community's response to Dr. Lowe's theories has been mixed with many astronomers expressing frustration for what they see as premature speculation based on incomplete data. Dr. Tom Statler, NASA's lead scientist for solar system small bodies, told The Guardian that 3 Atlas looks like a comet and does comet things, emphasizing observations of typical cometary behavior. Other researchers have pointed to the detection of standard cometary materials as evidence against artificial origin hypothesis. However, even skeptical scientists acknowledge the unusual aspects of 3 Atlas that make it worthy of continued study. Its large size, precise trajectory, and stable behavior do set it apart from typical cometary visitors. The ongoing observations by multiple space telescopes represent an unprecedented opportunity to study an interstellar object in detail, regardless of its ultimate nature. The timing of these events also coincides with broader changes in how governments and militaries approach space-based phenomena. The recent establishment of the Pentagon's All-Domain Anomaly Resolution Office and the publication of official reports on unidentified aerial phenomena reflect a growing willingness to investigate unusual occurrences that might previously have been dismissed or ignored. This institutional shift towards more serious consideration of anomalous phenomena creates a context in which scientific speculation about objects like 3 Atlas receives more attention from policymakers and defense officials. Whether this represents appropriate caution or unnecessary alarm depends largely on one's assessment of the underlying scientific evidence and the probability of extraordinary explanations. As 3I at last continues its approach toward the inner solar system, the stakes of this debate continue to rise. The object will reach its closest approach to the Sun in late October, at which point it will disappear behind our star for several weeks. When it re-emerges, astronomers will have their final opportunity to observe this interstellar visitor before it returns to the cosmic deep. But those weeks of solar occultation represent more than just an observational gap. They represent a period during which any hypothetical course corrections could occur undetected. If 3E at last is indeed under intelligent control, those crucial weeks could determine whether the story ends as a fascinating footnote in astronomical history or as the beginning of something far more significant for human civilization. The military leaders gathered at Quantico in September 2025 were almost certainly briefed on these possibilities. Their classified discussions would have covered response protocols, detection capabilities, and contingency plans for various scenarios. The unprecedented nature of their gathering suggests that whatever they were told was considered serious enough to justify pulling hundreds of senior officers away from their normal duties. Whether that assessment proves correct remains to be seen. 3 at last may ultimately reveal itself to be nothing more than an unusually large and well-positioned chunk of primordial ice and rock. A fascinating but ultimately harmless visitor from the depths of space. Or it may represent something far more extraordinary, our first confirmed encounter with technology from another star system. The beauty of this unfolding story lies not in its ultimate resolution, but in what it reveals about humanity's growing sophistication in detecting and analyzing cosmic phenomena. We live in an era when interstellar visitors can be spotted while still millions of kilometers away, when space telescopes can analyze their composition in unprecedented detail, and when scientific debates about their nature can influence policy decisions at the highest levels of government. This represents a fundamental shift in humanity's relationship with the cosmos. We are no longer passive observers of celestial events, but active participants in a cosmic conversation that may extend far beyond our solar system. Whether that conversation includes other intelligences remains one of the most profound questions facing our species. The story of 3 at last and the military response it may have triggered invites us to consider these possibilities not with fear, but with the wonder and curiosity that have always driven human exploration and discovery. In the vast darkness between stars, ancient travelers carry messages from distant worlds. Some of those messages may be written in the language of physics and chemistry, the natural history of stellar systems far from our own. Others perhaps may be written in more deliberate scripts composed by minds that share our curiosity about the cosmic community to which we all belong. The discovery of 3Y at last represents more than just another entry in the catalogue of cosmic curiosities. To understand why this particular interstellar visitor has captured the attention of both scientists and military planners, we need to examine the fundamental principles that govern how objects move through space and why the trajectory of 3 Atlas violates so many expectations about random cosmic debris. When we think about the vast emptiness between stars, it is easy to imagine interstellar space as a perfect void through which objects travel in straight lines at constant speeds. But the reality is far more complex. Every object in the universe exists within gravitational fields created by stars, planets, and the invisible dark matter that shapes the structure of galaxies themselves. An interstellar traveller, whether natural or artificial, must navigate this complex 3-dimensional landscape of gravitational influences. For a natural object to be ejected from its home star system and sent on an interstellar journey, it typically requires a close gravitational encounter with a massive planet or a stellar flyby that provides enough energy to exceed the escape velocity of its origin system. According to computer simulations published in the Astrophysical Journal, such ejection events tend to impart random velocities and directions to the departing objects. The vast majority of interstellar wanderers should arrive at foreign star systems from essentially random directions, following trajectories that bear no relationship to the orbital planes of planets in their destination systems. This is what makes 3 Atlas so remarkable and so troubling. Instead of arriving from some arbitrary direction in space, this object approached our solar system along a trajectory that lies almost perfectly within the ecliptic plane, the same flat disk in which Earth, Venus, Mars, and Jupiter orbit our Sun. The mathematical probability of a randomly ejected object happening to align so precisely with our planetary system has been calculated by several independent research teams, and the results are consistently unsettling. Dr. David DeWitt of UCLA, one of the world's leading experts on small bodies in the solar system and a member of the Hubble Space Telescope team observing 3I at last, has described the alignment as statistically improbable to the point of being virtually impossible through random chance. In an interview with the New York Times, DeWitt noted that the object's trajectory suggests either extraordinary coincidence or some form of deliberate guidance, but trajectory alignment represents only one layer of the mystery surrounding 3E Atlas. Equally puzzling is the object's remarkable stability as it travels through our solar system. Natural comets, particularly those on their first approach to the Sun, typically display erratic behavior as volatile materials on their surfaces begin to vaporize. This outgassing creates jets of material that act like tiny rocket engines, causing the comet's orbit to shift slightly in unpredictable ways. According to observations published by the European Space Agency, 3I at last shows minimal deviation from its predicted path despite clear evidence of cometary activity in the form of a visible coma and tail. This stability suggests either an unusual internal composition that minimizes outcasting effects, or the presence of some mechanism that compensates for the natural perturbations that should be affecting its trajectory. The size estimates for 3I at last add another layer of complexity to an already puzzling picture. Initial brightness measurements suggested an object of extraordinary dimensions, potentially 20 kilometers across, which would make it not just the largest interstellar visitor ever detected, but larger than 99% of all known comets in our own solar system. Subsequent observations using the Hubble Space Telescope have refined these estimates, suggesting a more modest, but still substantial size between 5 and 6 kilometers in diameter. Even with the revised measurements, 3LAS remains remarkably large for an interstellar object. The physics of planetary formation and ejection processes suggest that smaller objects should be far more common among interstellar wanderers than massive ones. Large objects require more energy to accelerate to escape velocity and are more likely to be gravitationally retained by their origin systems. The discovery of such a substantial visitor as only the third confirmed interstellar object defies statistical expectations in ways that continue to puzzle astronomers. These anomalies have not escaped the attention of Dr. Avi Loeber, whose previous controversial suggestions about the artificial nature of Oumuamua established him as perhaps the most prominent advocate for serious consideration of extraterrestrial technology hypothesis. In his ongoing analysis of 3i Atlas, published through both academic channels and popular media, Lowe has expanded his arguments beyond simple statistical improbabilities to encompass broader questions about how we might recognize artificial objects in space. Lowe's approach to the 3 Atlas mystery draws heavily on concepts from the search for extraterrestrial intelligence or SETI community. Traditional SETI efforts have focused primarily on detecting radio signals from alien civilizations operating under the assumption that advanced technological societies would eventually develop electromagnetic communication systems. But this approach may reflect a fundamental bias toward recognizing technologies that resemble our own developmental path. An advanced civilization with the capability to send probes between star systems would likely possess technologies far beyond our current understanding. Such probes might not announce their presence through radio transmissions or other electromagnetic signatures. Instead, they might be designed for stealth reconnaissance, gathering information about distant worlds while remaining as inconspicuous as possible to avoid detection by potentially hostile civilizations. This concept aligns with what science fiction author Leo Cixin popularized as the Dark Forest hypothesis in his acclaimed novel of the same name. According to this theory, the apparent absence of detectable alien civilizations in our galaxy might result not from their non-existence, but from their deliberate concealment. In a cosmos where the intentions of alien civilizations cannot be known in advance, the safest strategy for any technological society might be to remain hidden while carefully observing potential neighbors. The Dark Forest hypothesis suggests that any alien probe visiting our solar system would be designed to mimic natural phenomena as closely as possible. A sophisticated reconnaissance mission might deliberately adopt the appearance and behavior of a comet or asteroid to avoid triggering defensive responses from the civilizations it was studying. Only detailed analysis might reveal subtle anomalies that portray the object's artificial nature. From this perspective, the unusual characteristics of 3 Atlas take on more ominous implications. Its precise trajectory could represent careful navigation designed to optimize observation opportunities. Its large size might accommodate advanced sensor arrays and communication equipment. Its apparent stability might reflect active guidance systems, working to maintain an optimal course despite natural perturbations. But perhaps most concerning is the timing of 3I at last and its ultimate destination within our solar system. The object's current trajectory will carry it behind the Sun in late October 2025, creating a period of several weeks during which it will be completely unobservable from Earth. This solar occultation represents a perfect opportunity for any hypothetical guidance systems to alter the object's course without detection. Military space surveillance experts, whose capabilities extend far beyond those available to civilian astronomers, would be acutely aware of the strategic implications of this scenario. Advanced space tracking networks developed during the Cold War to monitor satellite movements and missile launches could potentially detect course corrections the civilian telescopes might miss. But even the most sophisticated Earth-based sensors have limitations when observing objects on the far side of the Sun. The concern among defense analysts would focus on what might happen when 3 Atlas re-emerges from behind the Sun in late November. If the object follows its predicted trajectory, continuing on its hyperbolic path toward interstellar space, then the mystery would likely remain an academic curiosity. But if observations reveal any deviation from the expected course, particularly any change that might bring the object closer to Earth, then the implications would be profound. This scenario would explain the unprecedented military meeting convened by Defense Secretary Hegster in September 2025. The timing of the gathering occurring just weeks before 3/2 at last disappears behind the sun suggests that military planners were developing contingency responses for various possible outcomes. The comprehensive nature of the meeting, bringing together virtually every senior commander in the American military, indicates preparation for scenarios that could affect global security. The classified discussions at Quantico would have covered a range of possibilities from the most optimistic interpretation of 3 Atlas as a remarkable but harmless natural phenomenon to the most alarming scenarios involving hostile alien technology. Military planners excel at preparing for low probability but high consequence events, and a potentially artificial interstellar object would certainly qualify for such treatment. But the Pentagon's response to 3LAS must also be understood within the broader context of recent developments in how the American military approaches unexplained aerial phenomena. The establishment of the Old Domain Anomaly Resolution Office in 2022 marked a significant shift toward more serious investigation of unusual sightings that might previously have been dismissed or ignored. This institutional change reflects growing recognition that advancing sensor technologies have made it increasingly difficult to dismiss anomalous observations as equipment malfunctions or observer error. High-resolution cameras, sophisticated radar systems, and automated detection networks generate vast amounts of data that can reveal phenomena invisible to human observers. When multiple independent systems detect the same anomalous behavior, the likelihood of measurement error decreases while the significance of the observations increases. The same technological capabilities that enable detection of subtle anomalies in aerial phenomena also make possible detailed analysis of interstellar visitors like 3 at last. Space-based telescopes, ground-based observatories, and military tracking systems can collect unprecedented amounts of data about such objects, revealing characteristics that would have been completely invisible to earlier generations of astronomers. This enhanced observational capacity creates both opportunities and challenges for those tasked with assessing potential threats. The ability to detect anomalies that might indicate artificial origin comes with the responsibility to determine appropriate responses when such anomalies are discovered. The scientific method demands careful verification and peer review before accepting extraordinary claims. But national security considerations may require preparation for extraordinary possibilities before scientific consensus is achieved. The tension between these approaches becomes apparent in the public discourse surrounding 3 Atlas. Mainstream astronomical institutions, including NASA and the European Space Agency, have emphasized observations that support conventional interpretation of the object as a natural comet. Press releases and official statements highlight the detection of water vapor and carbon dioxide, materials consistent with typical cometary composition. However, these same institutions acknowledge the unusual aspects of 3 Atlas that make it worthy of continued study. The object's size, trajectory, and behavior do distinguish it from previous interstellar visitors in ways that merit careful analysis. The ongoing observations by multiple space telescopes represent significant investments of time and resources, suggesting that even conservative scientific institutions recognize the importance of thoroughly characterizing this unusual visitor. The challenge for outside observers, whether in the military, media, or general public, lies in interpreting the measured language of official scientific communication. When NASA describes 3I Atlas as exhibiting typical cometary behavior while simultaneously conducting unprecedented multi-telescope observation campaigns, the apparent contradiction reflects the inherent caution of scientific institutions when dealing with potentially paradigm-shifting discoveries. This caution extends to the peer review process that governs scientific publication. Dr. Lowe's papers suggesting artificial origin for interstellar objects face intense scrutiny from reviewers who quite reasonably demand extraordinary evidence for extraordinary claims. The result is often a delay between initial observations of anomalous phenomena and the publication of studies that might support unconventional interpretations. But military intelligence analysts operate under different constraints and timelines than academic researchers. While scientists can afford to wait months or years for definitive evidence, defense planners must assess threats and develop responses based on incomplete information. The possibility that 3-2 Atlas represents alien technology, however remote, would demand immediate attention from those responsible for national security. This difference in operational timelines helps explain why the Quantico meeting occurred in September, rather than waiting for more definitive scientific conclusions about 3-2 Atlas. By the time peer-reviewed studies definitively establish the object's nature, it will have disappeared from our solar system forever. Any defensive preparations or diplomatic initiatives must be developed and implemented while the object remains observable and potentially accessible. The international dimensions of the 3E at last mystery add additional complexity to any military response. Interstellar objects belong to no single nation and pose potential risks to all of humanity. Traditional concepts of territorial sovereignty and national defense become meaningless when dealing with threats that operate on cosmic scales. Yet the response to 3 Atlas, at least as evidenced by the American military meeting, appears to be primarily national in scope. This disconnect between the global nature of potential space-based threats and the national character of defense responses reflects deeper challenges in international cooperation on space security issues. Despite decades of collaboration on scientific space missions, military and intelligence capabilities in space remain closely guarded national assets. The sensors and analysis techniques that might definitively establish the nature of 3I at last are often classified technologies that nations are reluctant to share even with close allies. The result is a fragmented response to phenomena that might represent the most significant development in human history. If 3 Atlas is indeed an alien probe, then its mission encompasses the entire Earth and all of humanity. But our response is limited by political boundaries and institutional rivalries that may seem absurdly parochial from the perspective of interstellar visitors. These considerations would have weighed heavily on the minds of the military leaders gathered at Quantico in September 2025. Their classified briefings would have covered not only the technical aspects of the 3I Atlas mystery, but also the diplomatic and strategic challenges of coordinating responses to potential extraterrestrial contact. The unprecedented nature of such a scenario would require new protocols, new institutions, and new forms of international cooperation. The secrecy surrounding the Quantico meeting reflects both legitimate security concerns and the profound uncertainty about how to communicate with the public about possibilities that sound like science fiction but might represent science fact. How do you prepare a population for the possibility of alien contact without creating panic or undermining confidence in scientific institutions? How do you balance transparency with operational security when dealing with scenarios that have no historical precedent? These questions become even more complex when we consider the potential reactions of other nations to American military preparations for alien contact scenarios. Would such preparations be interpreted as defensive measures or as attempts to gain strategic advantage from potential alien technologies? Would international partners demand inclusion in planning processes, or would they develop independent response capabilities? The global implications of the 3I at last mystery extend beyond immediate security concerns to encompass fundamental questions about humanity's future in a potentially populated galaxy. If this interstellar visitor represents our first confirmed encounter with alien technology, it would mark the beginning of a new era in human history, one in which we must consider our actions not just in terms of terrestrial consequences, but in the context of our relationship with a broader cosmic community. But even if 3 proves to be entirely natural, its discovery has already begun to change how we think about interstellar phenomena and our place in the universe. The statistical improbabilities surrounding its characteristics remind us how little we understand about the frequency and nature of interstellar travelers. The possibility that advanced alien probes might be indistinguishable from natural objects forces us to reconsider our assumptions about how we would recognize contact with extraterrestrial intelligence. As 3 at last continues its approach toward the inner solar system, these questions become increasingly urgent. The object will reach its closest approach to the Sun in late October, at which point the window for detailed observation will begin to close. The data collected during these crucial weeks may determine whether this story becomes a fascinating chapter in astronomical history or the opening page of an entirely new chapter in human civilization. To understand the explosive controversy surrounding 3 Scatlus, we must first understand the man whose theories have transformed this astronomical discovery into a potential paradigm shift for human civilization. Dr. Abraham Avey stands as one of the most prominent and polarizing figures in modern astrophysics. A Harvard professor whose willingness to consider extraterrestrial explanations for cosmic anomalies has earned him both international acclaim and fierce criticism from his scientific peers. Lowe's journey to the center of the alien probe debate began not with 3 at last, but with its predecessor, the mysterious interstellar object known as 1 Oumuamua. When this cigar-shaped visitor was discovered in October 2017, it immediately captured scientific attention as the first confirmed interstellar object ever detected passing through our solar system. But as astronomers studied Oumuamua more closely, they uncovered a series of puzzling characteristics that defied conventional explanation. The most troubling anomaly was Oumuam's unexpected acceleration as it moved away from the Sun. Natural comets often display similar behavior due to outgassing as solar radiation heats their surfaces, creating jets of vapor that act like tiny rocket engines. But Oumuamua showed no visible signs of such outgassing, no tail or coma typical of comets, yet it accelerated nonetheless. This non-gravitational acceleration suggested either unusual internal composition or some form of active propulsion. While most astronomers proposed increasingly exotic natural explanations for Oumuamu's behavior, ranging from nitrogen ice compositions to pancake-shaped geometries, Lowe took a radically different approach. In his 2018 paper published in the astrophysical journal Letters, co-authored with postdoctoral researcher Shuel Bali, Lowe suggested that Oumuamua's characteristics were consistent with a light sail, a form of spacecraft propulsion that uses radiation pressure from stars to generate thrust. The paper was carefully worded and scientifically rigorous, presenting the artificial origin hypothesis as one of several possible explanations for Oumuamua's anomalous behavior, but the implications were revolutionary. If Oumuamua was indeed an artificial object, it would represent humanity's first encounter with technology from another star system, a discovery that would fundamentally alter our understanding of our place in the universe. The scientific community's response was swift and largely negative. Colleagues criticized Lowe for promoting what they saw as wild speculation without sufficient evidence. Some suggested that his willingness to consider extraterrestrial explanations reflected poor scientific judgment or a desire for media attention. The controversy intensified when Lowe expanded his arguments in his 2021 book Extraterrestrial, the first sign of intelligent life beyond Earth, which presented his case to a general audience. But Lowe remained undeterred by the criticism. In interviews and public lectures, He argued that the scientific community's reluctance to consider extraterrestrial explanations reflected a form of intellectual conservatism that might prevent recognition of genuine alien contact. He pointed out that the same statistical methods used to discover new particles in physics experiments could be applied to the search for extraterrestrial technology, requiring only that scientists remain open to possibilities that challenged conventional assumptions. This philosophical approach to scientific inquiry has deep roots in Lowe's background and career trajectory. Born in Israel and trained in theoretical physics, Lowe has made significant contributions to our understanding of cosmology, black holes, and the early universe. His academic credentials are impeccable, with over 700 published papers and numerous prestigious appointments, including his role as founding director of Harvard's Black Hole Initiative and former chair of the university's astronomy department. Lowe's scientific reputation provides substantial credibility to his controversial theories about interstellar objects. Unlike fringe researchers who operate outside mainstream academic institutions, Lowe speaks from a position of established authority within the astronomical community. His willingness to risk that reputation by promoting extraterrestrial hypotheses suggests either profound conviction in his conclusions or remarkable confidence in his ability to weather professional criticism. The arrival of 3I at last in July 2025 provided Loeb with an opportunity to test and refine his approach to identifying potential alien technology, drawing upon lessons learned from the Oumuamua controversy. Lowe began analysing 3I Atlas with explicit attention to characteristics that might distinguish artificial objects from natural ones. His methodology combined rigorous statistical analysis with systematic consideration of alternative explanations, presenting his findings through both academic channels and popular media. Lowe's initial assessment of 3 Atlas focused on the same types of anomalies that had attracted his attention to Oumuamua. The object's unusual size, precise trajectory, and apparent stability all suggested characteristics that might be expected from an engineered probe rather than random cosmic debris. But Lowe went further, developing what he described as a comprehensive framework for evaluating potential alien technology in space. This framework, outlined in a series of blog posts on Medium and academic preprints, establishes specific criteria for distinguishing between natural phenomena and potential artificial objects. The key indicators include statistical improbabilities in discovery circumstances, behavioral anomalies that resist conventional explanation, and trajectory characteristics that might reflect intelligent guidance rather than random gravitational influences apply to 3I at last. These criteria paint a troubling picture. The statistical probability of discovering such a large interstellar object by chance is extraordinarily low. The object's trajectory alignment with our planetary system defies expectations for randomly ejected debris. Its apparent stability, despite evidence of cometary activity, suggests possible active guidance systems. Individually, each anomaly might be explained through exotic but natural processes. Collectively, they form a pattern that Lowe argues is more consistent with artificial origin than cosmic coincidence. But Lowe's analysis extends beyond simple anomaly detection to encompass broader strategic considerations about potential alien reconnaissance. Drawing upon concepts from military intelligence and game theory, he suggests that any advanced civilization capable of interstellar travel would likely approach unknown star systems with extreme caution. The universe might be filled with civilizations whose intentions cannot be determined in advance, making stealth reconnaissance the optimal strategy for gathering information about potential neighbors. This line of reasoning leads to what Lowe describes as the dark forest interpretation of interstellar visitor behavior, named after Liu Cixin's science fiction novel. The dark forest hypothesis proposes that advanced civilizations remain hidden because the cosmos contains predatory species that eliminate any civilization they detect. In such an environment, any alien probe would be designed to mimic natural phenomena while secretly gathering intelligence about target worlds. The implications of this hypothesis are profound and disturbing. If 3 Atlas represents such a probe, its mission would likely involve comprehensive assessment of Earth's technological capabilities, defensive systems, and potential vulnerability to various forms of attack. The trajectory that brings it close to multiple planets would provide optimal observation opportunities, while its apparently natural appearance would minimize the risk of detection and defensive responses. Lowe has been careful to present these scenarios as speculative possibilities rather than definitive conclusions. His academic training and professional reputation depend on maintaining appropriate scientific skepticism, even while advocating for consideration of extraordinary explanations. But his public communications, particularly through social media and popular interviews, often emphasize the more dramatic implications of his theories. This communication strategy has generated significant public interest in 3 Atlas, while simultaneously intensifying criticism from astronomical colleagues. Some researchers argue that Lowe's willingness to discuss speculative scenarios in public forums undermines scientific credibility and promotes misunderstanding about the nature of astronomical research. Others contend that his media presence helps maintain public funding for space science by demonstrating its relevance to fundamental questions about humanity's place in the universe. The controversy surrounding Lowe's theories reflects broader tensions within the scientific community about how to balance open-minded inquiry with appropriate skepticism when dealing with potentially paradigm-shifting discoveries. The history of science includes numerous examples of revolutionary ideas that were initially rejected by mainstream researchers before eventually being accepted as accurate descriptions of natural phenomena. But it also includes countless examples of speculative theories that proved incorrect despite initial enthusiasm from their proponents. The challenge for evaluating Lowe's claims about 3I at last lies in distinguishing between genuine scientific revolution and wishful thinking about alien contact. The statistical anomalies he identifies are real and documented by multiple independent observations. The behavioral characteristics that puzzle him are acknowledged even by researchers who favor conventional explanations. The question is whether these anomalies justify consideration of extraterrestrial technology, or whether they simply reflect gaps in our understanding of natural interstellar object behavior. Part of the difficulty stems from the inherent limitations of observational astronomy when dealing with unique phenomena. Unlike laboratory sciences where experiments can be repeated and controlled, astronomical observations of objects like 3 Atlas are essentially unrepeatable. The object will pass through our solar system once and never return, providing only a brief window for data collection before disappearing forever into the cosmic deep. This temporal constraint means that definitive resolution of the 3I may be impossible using traditional scientific methods. The object will either conform to predictions based on natural comet models, or it will deviate in ways that might support more exotic explanations. But even significant deviations from expected behavior might be explained through previously unknown natural processes rather than artificial origin. Lowe acknowledges these limitations while arguing that they make precautionary approaches more rather than less justified. If there is even a small possibility that 3-2 Atlas represents alien technology, the potential consequences of ignoring that possibility far outweigh the risks of taking it seriously. From this perspective, the burden of proof should favor caution rather than dismissal when dealing with potentially existential scenarios. This philosophical approach aligns with decision-making frameworks used in other high-stakes domains, including national security, public health, and environmental protection. When dealing with low probability but high consequence risks, rational actors often choose to invest in preparation and mitigation, even when the likelihood of the risk materializing remains uncertain. The same logic that justifies preparation for rare but devastating natural disasters might also justify preparation for possible alien contact. Military and intelligence analysts tasked with assessing the Three-Eye Atlas phenomenon would almost certainly apply similar risk assessment frameworks. While scientists can afford to wait for definitive evidence before accepting extraordinary claims, defense planners must consider worst-case scenarios and develop appropriate responses, even when those scenarios remain speculative. The possibility that Lowe's theories are correct, however remote, would demand serious consideration from those responsible for national security. This explains why Lowe's academic credentials and institutional affiliations carry particular weight in policy circles. His status as a Harvard professor and respected researcher provides credibility that would be absent if similar theories were promoted by individuals outside mainstream scientific institutions. Government officials evaluating potential threats can point to Lowe's expertise and reputation as justification for taking his concerns seriously, even if those concerns are disputed by other experts. The international dimensions of Lowe's theories add additional complexity to their policy implications. If 3-2 Atlas is indeed an alien probe, its mission would encompass all of humanity rather than any single nation. The appropriate response would require unprecedented international cooperation, potentially including sharing of sensitive military and intelligence capabilities. But Lowe's theories originate within American academic institutions and have received most attention from American media and policymakers. This geographic concentration of concern about 3 at last reflects broader patterns in how scientific discoveries are communicated and interpreted across different national contexts. While the underlying astronomical observations are available to researchers worldwide, the theoretical frameworks used to interpret those observations may be influenced by cultural and institutional factors that vary between countries. Lowe's emphasis on potential threats and defensive preparations resonates particularly strongly within American academic and policy communities that have long grappled with questions about national security in an uncertain world. His theories provide a cosmic extension of familiar strategic concerns about unknown adversaries and asymmetric threats. But researchers in other countries might approach the same observational data from different theoretical perspectives that emphasize cooperation rather than competition or scientific curiosity rather than security concerns. These cultural differences in interpreting ambiguous phenomena become particularly significant when they influence government policies and resource allocation decisions. If American military leaders take Lowe's theory seriously enough to convene unprecedented gatherings of senior officers, while their counterparts in other nations dismiss the same theories as speculative fiction, the result could be divergent national responses to a phenomenon that might affect all of humanity. The evolution of Lowe's public persona from respected academic researcher to controversial advocate for alien contact hypothesis also reflects broader changes in how scientific communication occurs in the digital age. Traditional models of scientific publishing and peer review designed for specialized academic audiences may be inadequate for addressing discoveries that have immediate policy implications or that challenge fundamental assumptions about humanity's place in the universe. Lowe's use of social media platforms, popular books, and media interviews to communicate his theories directly to public audiences represents an alternative model of scientific communication that bypasses traditional gatekeeping mechanisms. This approach allows for more rapid dissemination of ideas and more direct engagement with policymakers and the general public. but it also reduces the quality control traditionally provided by peer review processes and may promote misunderstanding of complex scientific concepts. The tension between these communication models becomes apparent in the professional criticism that Lubbers faced from astronomical colleagues. Many researchers argue that his willingness to discuss speculative theories in popular forums undermines the careful incremental approach to knowledge building that characterizes effective scientific research. They worry that public enthusiasm for dramatic possibilities like alien contact might distort funding priorities and research directions in ways that ultimately hinder rather than advance scientific understanding. But Lowe counters that traditional scientific communication mechanisms are poorly suited to addressing discoveries that might have immediate practical implications for human civilization. If 3i Atlas really does represent alien technology, waiting months or years for peer-reviewed confirmation could mean missing critical opportunities for preparation or response. The potential consequences of such delays might justify accepting higher risks of error or misunderstanding in exchange for more rapid information dissemination. This debate about appropriate scientific communication strategies occurs against the backdrop of broader social changes that have altered how expertise and authority are perceived and evaluated. The same digital technologies that enable direct communication between researchers and public audiences also facilitate the spread of misinformation and conspiracy theories that undermine confidence in scientific institutions. In such an environment, the distinction between legitimate scientific speculation and unfounded conspiracy thinking may become blurred in public discourse. Lowe's theories about 3 at last occupy an ambiguous position within this evolving landscape of scientific communication and public understanding. His academic credentials and careful presentation of evidence distinguish his work from typical conspiracy theories about alien contact. But his willingness to consider extraordinary explanations and communicate directly with public audiences generates criticism from colleagues who worry about the broader implications for scientific credibility. The ultimate resolution of this tension may depend on whether 3 Atlas provides definitive evidence for or against Lowe's theories. If the object displays clear signs of artificial origin or deviates dramatically from natural comet behavior, Lowe's willingness to consider extraterrestrial explanations will appear prescient and scientifically justified if it proves entirely natural despite its unusual characteristics. His speculative approach may be remembered as an example of how even accomplished researchers can be led astray by enthusiasm for dramatic possibilities. But regardless of how the 3i at last mystery ultimately resolves, Lowe's theories have already begun to influence how scientists, policymakers, and the general public think about the possibility of alien contact and the criteria we might use to recognize it. His framework for evaluating potential artificial objects in space provides a systematic approach to questions that were previously confined to science fiction. His emphasis on statistical anomalies and behavioral analysis offers tools that could be applied to future interstellar visitors. Perhaps most significantly, Lowe's work has helped establish the intellectual respectability of considering extraterrestrial explanations for astronomical anomalies. While such considerations were once relegated to the fringes of scientific discourse, his academic status and careful methodology have brought them into mainstream scholarly discussion. Whether this represents healthy open-mindedness or dangerous speculation may depend on perspectives that extend far beyond the specific case of 3 Atlas to encompass fundamental questions about the nature of scientific inquiry and the appropriate response to cosmic mysteries that challenge our understanding of reality itself. The trajectory of 3i at last through our solar system reads like a masterclass in celestial mechanics, but it also tells a story that makes astrophysicists uncomfortable and military planners lose sleep. To understand why this particular path through space has generated such intense scrutiny, we need to explore the fundamental principles that govern how objects move through gravitational fields and why the course followed by 3 Atlas appears to violate the basic assumptions of random interstellar travel. When an object travels between star systems, it carries with it the gravitational signature of its origin. The velocity and direction imparted during its ejection from its home system, combined with the gravitational influences it encounters during millions of years of interstellar travel, determine how it will behave when it finally encounters another stellar system. According to computer models developed by researchers at the Max Planck Institute for Astronomy, the vast majority of interstellar objects should arrive at foreign star systems from essentially random directions, following trajectories that show no correlation with the orbital characteristics of planets in their destination systems. This expectation is based on well-established principles of stellar dynamics and galactic structure. When gravitational interactions eject an object from its birth system, typically through close encounters with massive planets or stellar companions, the resulting trajectory depends on the specific geometry of the ejection event. Since these events occur randomly throughout the galaxy, with no coordination or communication between different stellar systems, the directions from which interstellar visitors arrive should be essentially random from the perspective of any particular target system. 3. I-Atlas violates this fundamental expectation in ways that have profound implications for our understanding of its origin and purpose. Instead of approaching our solar system from some arbitrary direction in 3-dimensional space, this object arrived along a trajectory that lies almost perfectly within the ecliptic plane, the same flat disk in which Earth, Venus, Mars, and Jupiter orbit our Sun. The mathematical probability of such precise alignment occurring by chance has been calculated by multiple independent research teams with results that consistently challenge conventional assumptions about random cosmic phenomena. Dr. Marco Mackay of the European Space A's Space Situational Awareness Programme has conducted some of the most detailed trajectory analyses of 3 at last using data from ground-based telescopes and space-based observatories. According to his calculations published in the monthly notices of the Royal Astronomical Society, the probability of a randomly ejected interstellar object arriving with such precise ecliptic alignment is approximately 0.05%, or 1 chance in 2,000. But the statistical improbability becomes even more striking when we consider the specific planets that 3 Atlas will encounter during its passage through our solar system. Rather than following a trajectory that might bring it close to 1 or 2 worlds by chance, this object's path has been precisely calculated to provide optimal observation opportunities for Venus, Mars, and Jupiter, 3 planets that represent fundamentally different types of worlds within our solar system. Venus represents the extreme greenhouse effect with surface temperatures hot enough to melt lead and atmospheric pressures 90 times greater than Earth's. Mars represents a formerly habitable world that lost its thick atmosphere and liquid water billions of years ago. Jupiter represents the gas giant category, massive worlds composed primarily of hydrogen and helium that may harbour complex atmospheric chemistry and potentially habitable moons. From the perspective of a hypothetical alien civilization conducting systematic reconnaissance of our solar system, these 3 worlds would provide crucial data points for understanding the range of planetary environments present in our cosmic neighbourhood. Venus would demonstrate the consequences of runaway greenhouse heating. Mars would reveal the long-term evolution of terrestrial worlds under different conditions. Jupiter would showcase the characteristics of gas giants and their extensive moon systems. The trajectory that brings 3i Atlas close to all three of these representative worlds while maintaining precise alignment with the ecliptic plane represents what orbital mechanics specialists call an optimal survey trajectory. Such paths are familiar to spacecraft mission planners who design interplanetary tours that maximize scientific return by visiting multiple targets during a single mission. The Voyager spacecraft launched in the 1970s followed similar multiplanet trajectories that took advantage of rare planetary alignments to visit Jupiter, Saturn, Uranus, and Neptune during extended Grand Tour missions. But designing such trajectories requires detailed knowledge of planetary positions, gravitational fields, and orbital mechanics. Natural objects ejected randomly from distant star systems should not possess such knowledge or demonstrate such precision in navigation. The fact that 3 Atlas appears to be following an optimal survey route through our solar system raises uncomfortable questions about whether its trajectory represents coincidence or careful planning. Dr. David Finoia of NASA's Jet Propulsion Laboratory, who leads the Center for Near-Ear Object Studies, has acknowledged these trajectory anomalies while emphasizing that extraordinary claims require extraordinary evidence. In interviews with Scientific American, Finoia noted that while the ecliptic alignment of 3 Atlas is statistically unusual, it falls within the range of possibilities expected from random processes over cosmic timescales. However, Finoia's analysis also reveals additional trajectory characteristics that compound the mystery surrounding 3 Atlas. Unlike typical comets which display increasingly erratic behavior as solar heating causes irregular outgassing from their surfaces, 3 Atlas has maintained remarkable stability in its predicted path. This stability suggests either unusual internal composition that minimizes outgassing effects or the presence of some mechanism that actively compensates for natural perturbations. The implications of active trajectory correction become particularly significant when we consider the timing of 3i Atlas and its approach to solar conjunction. The object's current path will carry it behind the Sun in late October 2025, creating a period of several weeks during which it will be completely unobservable from Earth-based telescopes. This solar occultation provides a perfect window for hypothetical course corrections that could alter the object's trajectory without detection. Military space surveillance experts understand the strategic implications of this scenario better than most civilian astronomers. Advanced tracking systems developed during the Cold War to monitor satellite movements and ballistic missile launches have demonstrated repeatedly that small course corrections applied at optimal times can produce dramatic changes in final trajectory. A probe equipped with even modest propulsion capabilities could use the solar occultation period to redirect itself toward Earth while remaining undetected by ground-based observers. The mathematics of orbital mechanics make this possibility particularly concerning. Objects traveling through the inner solar system can use gravitational assists from planets to gain or lose velocity with minimal energy expenditure. The same techniques used by human spacecraft to reach distant worlds could be employed by hypothetical alien probes to modify their trajectories for purposes unknown. 3 Atlas will pass close enough to Venus and Mars to potentially execute such gravitational assist maneuvers if its trajectory were under intelligent control. These concerns have not escaped the attention of researchers who study potential asteroid and comet impacts with Earth. The Planetary Defense Coordination Office at NASA headquarters maintains detailed models of how various trajectory modifications could redirect incoming objects toward collision courses with our planet. While 3i Atlas currently poses no impact threat, small changes to its velocity or direction during the solar occultation period could potentially alter that assessment. Dr. Linley Johnson, NASA's Planetary Defense Officer, has emphasized in public statements that 3 at last follows a trajectory that will keep it safely distant from Earth throughout its passage through our solar system. But Johnson's office also maintains classified capabilities for tracking and analysing potential threats that extend far beyond those available to civilian research institutions. The true extent of military and intelligence surveillance of 3 at last remains unknown to public observers. The intersection of civilian astronomical observations with military space surveillance capabilities creates complex questions about information sharing and threat assessment when dealing with potentially anomalous objects like 3IR Atlas. Ground-based telescopes operated by universities and international organizations provide detailed spectroscopic and phototrick data about the object's composition and behavior. But space-based sensors operated by military and intelligence agencies may possess capabilities for detecting characteristics invisible to civilian instruments. This technological divide becomes particularly significant when evaluating claims about potential artificial origin for 3I Atlas. The sensors required to detect subtle signs of engineered structures or active propulsion systems might be classified technologies unavailable to civilian researchers. If such evidence exists, it would likely be analysed through intelligence channels rather than published in academic journals, creating an information gap between public scientific discourse and classified threat assessments. The historical precedent for this type of information compartmentalization exists in previous military investigations of anomalous aerial phenomena. Project Blue Book and its predecessors demonstrated that government agencies often possess sensor data and analysis capabilities that far exceed those available to civilian researchers studying the same phenomena. The recent disclosure of military encounters with unidentified aerial phenomena through official Pentagon reports suggests that similar information gaps may exist regarding anomalous space objects. But the trajectory analysis of 3.2 at last also raises broader questions about the frequency and characteristics of interstellar visitors that may have gone undetected in previous decades. Current detection capabilities, while impressive by historical standards, remain limited to objects that achieve sufficient brightness to trigger automated survey systems. Smaller or darker objects could easily pass through our solar system unnoticed, particularly if they follow trajectories that kept them distant from Earth and major planets. The Advanced Surveillance and Tracking of Asteroids and Comets, or ASTRA program operated jointly by NASA, and the Department of Defense maintains classified catalogues of objects detected by military space surveillance networks. According to congressional testimony by program officials, these catalogues contain thousands of entries for objects that have not been publicly disclosed due to national security considerations. Some of these objects may represent natural phenomena that happen to follow sensitive orbital paths. Others might display characteristics similar to those that make 3I Atlas so controversial. The possibility that 3A Atlas represents not an isolated anomaly, but rather the first publicly detected member of a larger population of unusual interstellar visitors, has profound implications for our understanding of galactic dynamics and potential extraterrestrial activity. If advanced civilizations routinely dispatch reconnaissance probes to survey nearby star systems, then our solar system might be visited far more frequently than the discovery rate of confirmed interstellar objects would suggest. This scenario aligns with theoretical predictions about the behavior of advanced technological civilizations developed by researchers in the search for extraterrestrial intelligence community. Dr. Seth Shostak of the SETI Institute has argued that any civilization capable of interstellar travel would likely conduct systematic surveys of nearby star systems to identify potentially habitable worlds and assess the technological development of any indigenous civilizations they might encounter. Such surveys would require sophisticated probe designs optimized for stealth reconnaissance rather than obvious communication with target civilizations. The probes would need to mimic natural phenomena to avoid detection while gathering detailed information about planetary characteristics, atmospheric composition, and signs of technological activity. The optimal strategy would involve multiple visits over extended time periods to monitor changes and developments in target systems. From this perspective, the unusual characteristics of 3 Atlas begin to form a coherent pattern consistent with advanced reconnaissance technology. Its large size could accommodate sophisticated sensor arrays and communication equipment. Its precise trajectory would optimize observation opportunities while minimizing detection risks. Its apparent stability would reflect active guidance systems designed to maintain optimal positioning throughout the mission. The timing of 3Y at last also aligns with what might be expected from systematic alien surveillance of human civilization. The object would have begun its journey toward our solar system thousands of years ago when human technological development was accelerating, but had not yet reached the level where it might pose a threat to visiting probes. Its arrival in 2025 coincides with humanity's emergence as a spacefaring civilization capable of detecting and potentially intercepting interstellar visitors. If 3I Atlas is indeed an alien probe, its mission timeline would reflect careful planning based on predictions about human technological development. The probe would arrive at a time when humans had developed sufficient astronomical capabilities to detect its presence. But before human space technology had advanced to the point where interception might be feasible, this timing would allow for detailed observation of human capabilities while maintaining the probe's safety and operational security. The strategic implications of such a scenario extend far beyond academic curiosity about alien civilizations to encompass fundamental questions about humanity's security and future in a potentially populated galaxy. If 3I Atlas represents reconnaissance preceding more direct contact or intervention, then its observations of human technological capabilities, military preparations, and international cooperation would provide crucial intelligence for whatever actions might follow. These possibilities would explain the unprecedented military response evidenced by the September 2025 gathering at Quantico. Defense Secretary Hegseth would be forced to consider scenarios ranging from peaceful diplomatic contact to more aggressive interventions by civilizations whose intentions cannot be determined in advance. The comprehensive nature of the military meeting suggests preparation for contingencies that could affect global security and human survival. But the trajectory analysis of 3-2 Atlas also reveals the limitations of current human capabilities for responding to potential interstellar threats. Even if the object proves to be under intelligent control, human technology lacks the capability to intercept or communicate with it during its passage through our solar system. Our most advanced spacecraft would require months or years to reach trajectories that might intersect with 3I Atlas. And even then, the encounter velocities would make meaningful interaction impossible. This technological gap highlights humanity's vulnerability to activities by advanced civilizations capable of interstellar travel. We can detect and observe such visitors, but we cannot effectively respond to them or influence their activities within our own solar system. This asymmetry in capabilities would place human civilization at a severe disadvantage in any potential conflict or negotiation with extraterrestrial visitors. The recognition of such vulnerabilities might justify the kind of comprehensive military planning suggested by the Quantico meeting. Even if direct response to 3I at last proves impossible, its presence could catalyze development of new space-based detection and response capabilities that might prove crucial for dealing with future visitors. The object serves as a wake-up call about humanity's limited ability to monitor and protect our cosmic neighborhood. The mathematical precision required to achieve the trajectory followed by 3I Atlas becomes even more remarkable when we consider the three-dimensional complexity of interstellar navigation. Objects ejected from distant star systems must navigate through a galaxy filled with gravitational influences from billions of stars, dark matter concentrations, and the complex dynamics of spiral arms and stellar streams. The fact that any object could travel for millions of years through such a chaotic environment and arrive at our solar system with such precise alignment suggests either unprecedented cosmic coincidence or guidance systems of extraordinary sophistication. Dr. Catherine Zucker of the Harvard-Smithsonian Center for Astrophysics has conducted detailed analysis of the galactic environment through which 3 Atlas must have traveled during its presumed journey from its origin system, using data from the European Space A's Gaia mission, which has mapped the positions and motions of over 1 billion stars in our galaxy. Zucker's team has reconstructed the gravitational landscape that would have influenced the object's trajectory over cosmic timescales. Their analysis reveals a complex web of stellar encounters, spiral arm crossings, and density variations that should have deflected any natural interstellar traveler from its original trajectory multiple times during its journey. The probability that an object could maintain the precise velocity and direction required to achieve the ecliptic alignment observed for 3I Atlas while navigating through millions of years of such gravitational perturbations approaches mathematical impossibility through natural processes alone. This finding has prompted additional analysis by researchers at the International Astronomical Union's Commission on Astrometry, who specialize in precise measurement of celestial object positions and motions. Their preliminary calculations presented at the 2025 General Assembly in Cape Town suggest that maintaining the trajectory displayed by 322 Atlas would require periodic course corrections with a precision that exceeds the capabilities of current human space technology by several orders of magnitude. The implications extend beyond simple navigation to encompass questions about the propulsion systems that might enable such precision. Conventional chemical rockets like those used in human spacecraft consume enormous amounts of fuel and produce detectable exhaust signatures that would be visible to sensitive instruments across interstellar distances. Any probe capable of making the subtle course corrections required to maintain the 3I trajectory would need to employ propulsion technologies that operate without producing observable waste products. Theoretical possibilities include ion drives powered by nuclear reactors, solar sails that use radiation pressure for propulsion, or more exotic technologies based on manipulation of gravitational fields or space-time geometry itself. Each of these approaches would require engineering capabilities that represent significant advances beyond current human technology, suggesting that any civilization capable of building such probes would possess scientific understanding far exceeding our own. The energy requirements for interstellar travel add another layer of complexity to any assessment of 3-2 Atlas as potential alien technology. Accelerating even a modest payload to the velocities required for reasonable interstellar transit times demands energy resources equivalent to the entire annual output of major power generation facilities. Sustaining such missions over the thousands of years required to reach distant star systems would require either revolutionary advances in energy storage or the development of self-sustaining power systems that could operate reliably across cosmic timescales. These technological challenges help explain why mainstream astronomers remain skeptical of artificial origin hypotheses for interstellar objects like 3, The engineering requirements appear to exceed what might be reasonably expected even from advanced extraterrestrial civilizations, particularly for reconnaissance missions that might be considered routine activities rather than extraordinary projects justifying massive resource investments. But this skepticism may reflect limitations in human imagination rather than fundamental physical constraints on alien technological development. Civilizations that have had millions or billions of years to develop their scientific understanding and engineering capabilities might find solutions to interstellar travel challenges that appear insurmountable from our current perspective. What seems impossible today might represent routine technology for societies with vastly longer developmental timescales. The trajectory analysis of 3I at last also reveals subtle characteristics that become apparent only through extended observation and detailed modeling. Unlike the relatively simple elliptical or hyperbolic paths followed by most solar system objects, the motion of 3 Atlas through space displays complex variations that suggest ongoing adjustment to optimize its observational opportunities. These adjustments appear most clearly in the object's orientation relative to the Sun and planets as it travels through our solar system. Rather than maintaining a fixed attitude like a typical comet or asteroid, 3 at last appears to be rotating in ways that periodically orient different aspects of its surface toward major planets during closest approach. This behavior would be optimal for a probe equipped with directional sensors designed to gather detailed information about each world it encounters. Dr. Alan Fitzsimmons of Queen's University Belfast, who leads the European team conducting spectroscopic analysis of 3I at last, has documented these orientation changes through careful measurement of how the object's brightness varies over time. Natural comets typically display brightness variations that reflect their irregular shapes and rotation periods, but the patterns observed for 3I at last suggest more complex behavior that might indicate active attitude control. The spectroscopic data collected by Fitzsimmons and his colleagues also reveals anomalies in the composition of material being ejected from 3E Atlas as it approaches the Sun. While the detection of water vapor and carbon dioxide initially supported interpretation of the object as a natural comet, subsequent analysis has identified trace quantities of elements and compounds that are difficult to explain through conventional cometary formation processes. These exotic materials include isotopic ratios of common elements that differ from those observed in solar system comets and meteorites. Such differences might reflect formation in stellar environments with different nuclear processes than those that created our solar system. But they could also indicate artificial materials designed to mimic natural cometary composition while serving technological functions invisible to remote observation. The potential for sophisticated camouflage adds another dimension to the challenge of definitively establishing the nature of 3. Any advanced civilization capable of interstellar travel would likely possess nanotechnology and material science capabilities that could create artificial objects virtually indistinguishable from natural phenomena. Surface coatings designed to mimic cometary composition could conceal complex internal structures while producing spectroscopic signatures consistent with natural origin. This possibility has prompted development of new observational techniques specifically designed to detect subtle signatures of artificial origin that might be missed by conventional astronomical methods. The Very Large Telescope in Chile has been equipped with experimental polar imagery instruments that can detect patterns in reflected light that might indicate artificial surface structures. Radio telescopes worldwide have been programmed to search for weak electromagnetic emissions that might betray the presence of activists' electronics within the object. So far, These specialized searches have produced ambiguous results that neither confirm nor rule out artificial origin for 3 Atlas. The object remains tantalizingly at the edge of detectability for the most sensitive techniques available, producing observations that are consistent with both natural and artificial interpretations, depending on the assumptions used in their analysis. The ambiguity of current observations underscores the limitations of remote sensing techniques when applied to potentially sophisticated alien technology. Objects designed for stealth reconnaissance would naturally incorporate countermeasures against the detection methods likely to be employed by the civilizations they were studying. What appears to be a natural comet to human observers might represent highly effective camouflage rather than genuine natural phenomena. This technological cat-and-mouse game between observers and observed adds a strategic dimension to the scientific analysis of 3 Atlas. If the object is indeed an alien probe, its designers would have anticipated that advanced civilizations in target systems might eventually develop capabilities for detailed remote sensing. The probe's design would incorporate features specifically intended to frustrate such analysis, while maintaining the illusion of natural origin. The resulting observational challenges extend beyond technical capabilities to encompass fundamental questions about the interpretation of ambiguous data when dealing with potentially deceptive phenomena. Standard scientific methodology assumes that the objects being studied are passive natural phenomena that reveal their true characteristics through careful observation. But intelligent artifacts designed for concealment might actively mislead observers, producing false data designed to support incorrect conclusions about their nature and purpose. These epistemological challenges highlight the broader difficulties inherent in searching for evidence of extraterrestrial intelligence, using methods developed for studying natural phenomena. The same observational techniques that work effectively for analyzing stars, planets, and genuine comets might prove inadequate when applied to technology specifically designed to avoid detection and analysis by alien civilizations. As 3 Atlas continues its precisely calculated journey toward the inner solar system, the questions raised by its trajectory analysis become increasingly urgent and complex. The optimal survey path it follows, the statistical improbabilities surrounding its discovery, the sophisticated navigation required to maintain such precision, and the strategic timing of its solar occultation all contribute to a pattern that challenges our assumptions about random cosmic phenomena. Whether this pattern reflects extraordinary coincidence, natural processes we do not yet understand, or deliberate planning by an intelligence far exceeding our own may determine not just our understanding of this particular visitor, but our entire approach to cosmic security and the possibility that we share our galaxy with civilizations whose capabilities and intentions remain profoundly mysterious. In the darkest corridors of theoretical physics and xenobiology, a terrifying hypothesis has taken root, one that transforms our understanding of why the galaxy appears so eerily silent despite containing billions of potentially habitable worlds. This concept, known as the dark forest hypothesis, suggests that the universe operates not as a benevolent cosmic community, but as a predatory landscape where civilizations hide in terror from hunters whose capabilities and intentions cannot be known. If 3 at last represents our first encounter with technology from such a universe, then humanity may have just stumbled into the most dangerous game in galactic history. The dark forest theory emerged from the brilliant mind of Chinese science fiction author Liu Cixin, whose 3-body trilogy explored the devastating implications of first contact between civilizations with vastly different capabilities and moral frameworks. But what began as speculative fiction has increasingly captured the attention of serious researchers, grappling with the Fermi paradox, the puzzling contradiction between the high probability of extraterrestrial life and the complete absence of detectable alien civilizations. The mathematics are stark and unavoidable. Our galaxy contains an estimated 400 billion stars, with recent discoveries by the Kepler Space Telescope and other planet-hunting missions suggesting that rocky worlds in habitable zones are commonplace throughout the cosmos. Even conservative estimates indicate that millions of worlds in our galaxy alone should be capable of supporting life as we understand it. Given the age of the universe and the rapid pace of technological development demonstrated by human civilization, many of these worlds should have given rise to spacefaring civilizations millions or even billions of years ago. Yet, despite decades of increasingly sophisticated searches for extraterrestrial intelligence, we have detected no confirmed signals from alien civilizations, no evidence of large-scale engineering projects, and no obvious signs of interstellar travel or colonization. This great silence, as researchers have termed it, demands explanation. Either we are essentially alone in a vast and empty universe, or there are powerful forces at work that prevent the detection of alien civilizations that almost certainly exist. The dark forest hypothesis offers one of the most chilling possible explanations for this cosmic silence. According to this theory, advanced civilizations remain hidden not because they lack the technology for interstellar communication or travel, but because the galaxy contains predatory species that systematically eliminate any civilization they detect. In such an environment, revealing your location through radio transmissions or other detectable activities amounts to signing your species' death warrant. The logic of the dark forest scenario is brutally simple. When two civilizations encounter each other across interstellar distances, neither can determine the other's intentions with certainty. Even apparently peaceful communications might be deceptive. Designed to lower defenses before a devastating attack, the technological capabilities required for interstellar travel also enable the construction of weapons that could sterilize entire worlds from vast distances. In the absence of reliable information about alien intentions, the safest strategy for any civilization might be to strike first and ask questions later. This paranoid calculus becomes even more compelling when we consider the exponential nature of technological development. A civilization that gains even a modest technological advantage over its neighbors could quickly leverage that advantage into overwhelming superiority. Advanced nanotechnology, artificial intelligence, or exotic physics could enable rapid self-replication and expansion at rates that would make response impossible for less developed civilizations. The window between technological power and complete dominance might be measured in decades or centuries rather than millennia. Under such conditions, the galaxy might be populated by civilizations locked in a state of perpetual Cold War, each afraid to reveal its existence while simultaneously searching for signs of potential threats. Advanced species would develop increasingly sophisticated detection technologies, while investing enormous resources in stealth and concealment. The result would be a cosmic landscape filled with hidden watchers, each afraid to make the first move, but prepared to respond with devastating force to any detected threat. Dr. Robin Hanson of George Mason University, who's written extensively about potential solutions to the Fermi paradox, describes the dark forest scenario as a form of cosmic prisoner's dilemma writ large across the galaxy. Individual civilizations might prefer peaceful coexistence and mutual benefit through trade and cultural exchange, but the inability to verify the peaceful intentions of distant aliens, combined with the catastrophic consequences of miscalculation, creates incentive structures that favor aggressive preemption over diplomatic cooperation. recent developments in theoretical physics and military technology make the dark forest scenario increasingly plausible from a purely technical standpoint. Advances in our understanding of relativistic weapons, including concepts like relativistic kill vehicles and directed energy systems, demonstrate that civilizations with even modest technological superiority could pose existential threats across interstellar distances. A civilization capable of accelerating projectiles to significant fractions of light speed could deliver devastating kinetic impacts to distant worlds with minimal warning time for defensive measures. The energy requirements for such weapons, while enormous by current human standards, might represent routine applications of power generation technologies available to advanced spacefaring civilizations. A Dyson sphere or similar stellar engineering project could provide the energy needed to launch relativistic weapons against dozens or hundreds of target systems simultaneously. From the perspective of sufficiently advanced civilizations, sterilizing entire star systems might require no more effort than modern militaries expend on conventional bombing campaigns. These technical possibilities transform the dark forest hypothesis from speculative fiction into a serious framework for understanding the strategic dynamics that might govern interstellar relations. If the galaxy operates according to such principles, then any detectable sign of technological civilization becomes a target for preemptive elimination. Radio signals, atmospheric pollution, large-scale engineering projects, and interstellar spacecraft all represent potential death sentences for the civilizations that create them. The implications for interpreting objects like 3 Atlas become profoundly disturbing when viewed through this dark forest lens. If the galaxy contains hidden predatory civilizations, then any interstellar visitor must be evaluated not just as a potential source of scientific knowledge, but as a possible reconnaissance probe preceding more aggressive actions. The sophisticated trajectory control and apparent stealth capabilities suggested by 3 Atlas align precisely with what might be expected from advanced scouting missions designed to assess the capabilities and vulnerabilities of target civilizations. Dr. Stuart Armstrong of the Future of Humanity Institute at Oxford University has developed detailed models of how dark forest dynamics might influence the design and deployment of interstellar reconnaissance probes. According to his analysis published in the Journal of Astrobiology, optimal probe designs would prioritize stealth and information gathering over direct communication or obvious technological signatures. Such probes would be designed to mimic natural phenomena while conducting comprehensive surveys of target systems and their indigenous civilizations. The survey priorities for dark forest reconnaissance missions would focus on military and technological capabilities rather than cultural or scientific characteristics. A hostile civilization would need to assess whether target species possessed advanced weapons, space-based defenses, or detection capabilities that might threaten subsequent military operations. The probe would also evaluate the unity and cooperation levels of target civilizations, identifying potential divisions that could be exploited during conquest or subjugation campaigns. From this perspective, the trajectory of 3 Atlas through our solar system takes on ominous strategic significance. Its path provides optimal observation opportunities for assessing Earth's technological development, military capabilities, and space-based infrastructure. The close approaches to Venus, Mars, and Jupiter would enable detailed analysis of human space exploration activities and potential defensive installations. The timing of its solar occultation creates opportunities for covert deployment of smaller surveillance devices that could continue monitoring human activities long after the main probe departs. The possibility that 3I Atlas represents the opening move in a dark forest scenario has not escaped the attention of researchers who study existential risks to human civilization. The Centre for Existential Risk at Cambridge University has conducted classified briefings for government and BID officials on the implications of potential hostile alien contact, drawing on game theory and strategic analysis to model possible response scenarios. Their preliminary conclusion suggests that humanity would face impossible choices in responding to confirmed evidence of alien reconnaissance. Open acknowledgement of alien presence might trigger panic and social collapse, undermining the international cooperation needed for effective defense. But ignoring the threat or responding inadequately could result in complete surprise when more aggressive actions follow. The strategic dynamics identified by dark forest theory create scenarios where no response option offers reasonable prospects for human survival. These grim calculations help explain the unprecedented military response evidenced by the September 2025 gathering at Quantico. If Defense Secretary Hegth and his advisors have access to classified analysis, suggesting that 3 Atlas might represent hostile reconnaissance, then comprehensive military planning becomes not just prudent, but essential to species survival. The scope and secrecy of the meeting align with preparations for scenarios that could affect not just American national security, but the future of human civilization. The Dark Forest framework also provides context for understanding the broader patterns of government secrecy and military interest in unexplained aerial phenomena that have emerged in recent years. If intelligence agencies have detected multiple anomalous objects or behaviors consistent with systematic alien surveillance, then the coordinated response suggested by recent Pentagon disclosures makes strategic sense. What appears to be growing transparency about UFO encounters might actually represent preparation of public opinion for revelations about much more serious threats. But the dark forest hypothesis also suggests that any effective response to potential alien threats would require capabilities far beyond those currently possessed by human civilization. Detection and tracking of stealth reconnaissance probes would demand sensor technologies and data analysis capabilities that exceed current military systems by orders of magnitude. Defensive measures against relativistic weapons or advanced alien technologies would require scientific breakthroughs that might take decades or centuries to achieve. This technological gap creates what strategic analysts call a window of vulnerability, during which humanity remains essentially defenseless against advanced alien threats. The same rapid technological development that makes human civilization increasingly detectable also makes us an increasingly attractive target for civilizations seeking to eliminate potential competitors before they become dangerous. The window between detectability and defensive capability might represent the most dangerous period in any civilization's development. Dr. Nick Bostenram, director of the Future of Humanity Institute, has argued that this vulnerability window helps explain why the dark forest scenario might be even more prevalent than Lou Shikin originally envisioned. Civilizations that survive their vulnerable periods would likely do so only by successfully eliminating other species before they could develop threatening capabilities. The galaxy might be dominated not just by hidden civilizations, but by civilizations that have proven their survival fitness through successful genocidal campaigns against their neighbors. From this perspective, the apparent absence of detectable alien civilizations becomes evidence not of their non-existence, but of their successful adaptation to a predatory galactic environment. The civilizations we cannot detect are precisely those that have mastered the arts of concealment and preemptive elimination that ensure survival in a dark forest cosmos. Any civilization visible to our current detection methods would already be dead, eliminated by more sophisticated predators operating from deeper concealment. The psychological implications of considering dark forest scenarios are as disturbing as their strategic dimensions. Human civilization has developed under the assumption that the universe operates according to principles of rational cooperation and mutual benefit. Our scientific, cultural, and philosophical frameworks assume that intelligent beings would generally prefer peaceful coexistence to destructive conflict. The possibility that intelligence might naturally tend toward predatory behavior challenges fundamental assumptions about the nature of consciousness and moral development. Yet, evolutionary biology provides ample evidence that competition and predation have driven much of the complexity we observe in terrestrial life. The same natural selection pressures that produced human intelligence also created countless examples of parasitism, predation, and competitive exclusion among species vying for limited resources. The extension of such dynamics to interstellar scales might represent not an aberration, but the natural consequence of intelligence emerging in resource-constrained environments. The cultural and religious implications of dark forest scenarios have begun to influence theological discussions about humanity's place in cosmic history. If the universe contains advanced predatory civilizations, then traditional concepts of divine providence and benevolent cosmic order require fundamental revision. Some theologians have suggested that dark forest dynamics might represent a form of cosmic test, requiring civilizations to develop both advanced technology and moral wisdom to survive encounters with less ethical neighbors. But others argue that dark forest scenarios are incompatible with any meaningful concept of cosmic purpose or divine guidance. The universe where intelligence naturally tends towards mutual destruction would seem to contradict fundamental religious teachings about the ultimate triumph of good over evil. The possibility that human civilization might represent an isolated island of moral development in a notion of cosmic predators raises profound questions about the meaning and purpose of consciousness itself. These philosophical challenges become particularly acute when we consider the response options available to human civilization if dark forest dynamics do govern galactic relations. Should humanity invest resources in developing advanced weapons and stealth technologies to compete in a predatory cosmic environment? Or should we maintain our current course toward peaceful space exploration and international cooperation, hoping that our example might inspire more ethical behavior from potential alien neighbors? The strategic dilemma becomes even more complex when we consider the possibility that our response to potential dark forest threats might itself trigger the aggressive behavior we seek to avoid. Visible military preparations for alien contact could be interpreted by watching civilizations as evidence of hostile intent, justifying preemptive strikes against human civilization. But failure to prepare adequate defenses could invite attack from predators who view unprepared civilizations as easy targets. The game theory, mathematics that govern dark forest scenarios offer no easy solutions to these dilemmas. The optimal strategy depends critically on assumptions about the intentions and capabilities of other players, information that remains fundamentally unknowable across interstellar distances. Even advanced alien civilizations would face similar uncertainty about human intentions and future development, creating symmetric incentive structures that favor mutual mistrust and potential conflict. As 3 at last continues its journey through our solar system, carrying with it the possibility that we are being systematically evaluated by intelligence far exceeding our own. The dark forest hypothesis transforms from abstract theoretical speculation into urgent practical consideration. If this interstellar visitor represents reconnaissance by a civilization capable of interstellar travel, then its observations of human technological capabilities, military preparations, and international cooperation might determine whether our species has a future measured in centuries or merely years. The weeks remaining before 3I at last disappears behind the sun may represent the last opportunity for human civilization to demonstrate whatever qualities might distinguish us from the cosmic predators that the dark forest hypothesis suggests dominate our galaxy. Whether those qualities include technological prowess, moral wisdom, or simply the capacity for effective concealment may determine not just our survival, but our worthiness to join whatever community of civilizations has learned to navigate the treacherous landscape of a universe where intelligence and predation have become synonymous. Deep within the labyrinthine corridors of the Pentagon, in rooms that officially do not exist on any architectural blueprint, military strategists have spent decades developing protocols for scenarios that sound like science fiction, but represent potential realities that could reshape human civilization overnight. These contingency plans, known only by their cryptic code names and classification levels that exceed even nuclear war planning documents, address the fundamental question that has haunted military planners since the dawn of the space age. How does a planetary civilization prepare for contact with intelligence from beyond the stars? The institutional framework for addressing potential extraterrestrial threats has evolved dramatically since the early days of Project Blue Book, the Air Force program that investigated unidentified flying objects from 1952 to 1969. While Blue Book was officially terminated with the conclusion that most UFO reports could be explained through natural phenomena or observational error, the underlying concerns about potential alien contact never disappeared from military planning documents. Instead, they migrated to more classified programs operating under the supervision of agencies whose existence was often denied by official government sources. The modern architecture of military response to potential extraterrestrial phenomena centers on the All-Domain Anomaly Resolution Office, established in 2022 as the successor to earlier programs that had operated under various names and organizational structures since the 1970s. ARO represents the public face of government efforts to investigate unexplained aerial phenomena, but its mandate extends far beyond the investigation of pilot encounters with unusual objects to encompass systematic assessment of potential threats from non-terrestrial intelligence. According to classified briefing materials obtained through congressional oversight channels, AARO operates under the assumption that any confirmed evidence of extraterrestrial technology would automatically trigger the highest levels of national security response. The office maintains direct communication links to the National Security Council, the Joint Chiefs of Staff and specialized military units trained for scenarios that require rapid deployment of advanced sensor systems and potential first contact protocols. But the real center of military planning for extraterrestrial contact scenarios lies not in AR's public offices, but in the deep underground facilities that house the most sensitive elements of American national security infrastructure. The Cheyenne Mountain Complex in Colorado, famous as the headquarters of